Google is the company that wrote the paper the entire industry is built on. Attention is all you need, the transformer. Every large language model you have ever touched, including the ones now beating Google at its own game, traces its lineage back to a handful of researchers who sat inside Google. So when I tell you that in June of 2026, Google DeepMind stood up an emergency coding strike team. The company that invented the modern AI stack is now running a rescue mission to catch up in coding. That is the story today, and I have opinions about whether the rescue plan actually works because I do not think it does the thing they are telling you it does. Let me lay out what happened because the facts matter more than the spin. Over roughly 5 months, Google DeepMind lost 6 named researchers to its direct competitors. Denis Zhu, who founded Google Brain's reasoning team and whose chain of thought work underpins the reasoning behavior in basically every frontier model alive, quietly turned up at Meta's superintelligence lab. Noam Shazir, one of the original Transformer authors and a co-lead on Gemini, left for OpenAI. John Jumper, the AlphaFold Nobel laureate, went to Anthropic. Jonas Adler and Alexander Pritzel, who worked on coding and pre-training respectively. And one more left for a startup. In the single week those departures clustered, roughly $269 billion evaporated from Alphabet's market capitalization. Let that number breathe. That is not a rounding error. That is the market pricing in a real possibility, that the people who made Gemini good are no longer the people making Gemini, now before the worst of that exodus back in April. It is led by Sebastian Bourgeaud, who previously ran Gemini's pre-training, and it reports directly up through Sergey Brin and DeepMind's chief technology officer. The original mandate was coding tools and agentic development, but according to reporting from The Information, the team is now expanding its scope into something called midtraining. And here's where I need to stop and actually explain the mechanics, because the word midtraining is doing an enormous amount of quiet work in these headlines, and almost nobody covering this is telling you what it means or why it was chosen. So what is midtraining? A model gets built in phases. First, there is pre-training, where you take an enormous, general pile of text and code, and you train the model from scratch to predict the next token. This is the expensive part, the 9-figure compute run, the part that actually forms the model's deep representations of the world. Then at the far end, there is post-training, instruction tuning, reinforcement learning from human feedback, the polish that makes it helpful and safe to talk to. Mid-training sits in the gap between those two. You take a model that has already been pre-trained, and before you do the final tuning. The pitch is that you get domain-specific improvement without paying for a full pre-training run from scratch, and that pitch is completely legitimate. Mid-training is a real technique used across the industry. I am not here to tell you it is fake, but watch the logic of why it gets chosen. Mid-training is attractive precisely because it is cheaper and faster than pre-training. You do not have to burn a fresh-from-scratch run. It is the intervention you reach for when you need a result this quarter and you cannot afford to start over. And that timing tell, I think, is the whole story. This is not the plan you pick because it is the theoretically best plan. It is the plan you pick because it is the plan you can announce, staff, and show progress on inside a single quarter. It fits in a memo. That is a very different thing from being the plan most likely to win. A former DeepMind engineer, now at another lab, publicly disputed the entire premise. And his argument, which I think is the correct one from a pure engineering standpoint, is that the features that make a model genuinely good at code have to be established during pre-training, not bolted on afterward. Coding ability is not a sauce you drizzle on at the end. It is baked into how the model represents structure, how it tracks long-range dependencies. If those representations were not formed during the pre-training run, mid-training can sharpen them, but it cannot conjure them from nothing. You can take a model that already thinks structurally and make it more fluent in a specific style of code. What you cannot do is mid-train structural thinking into a model that never learned to think that way. That distinction, sharpening versus creating, is the difference between polishing a floor and pouring a new foundation. Google is describing a polish while, I would argue, actually facing a foundation problem. And there's a genuinely nasty practical wrinkle on top of that. The strike team's mid-training reportedly leans on Google's own internal code base, which is some of the cleanest, most consistent, best-reviewed code on the planet. That is fantastic training material. It is also a trap. Because you cannot cleanly ship a model trained on your proprietary monorepo without dragging that code's fingerprints, its patterns, potentially its literal snippets, along with it into whatever you release. So the very thing that would make the mid-trained model good, that pristine internal code, is the same thing that makes it legally and competitively awkward to put in front of outside customers. That is not a small footnote. But let me get to what actually bothers me most about the framing. Brin's internal memo, and I am quoting the reported language here, says Google must urgently bridge the gap in agentic execution and turn our models into primary developers of final code. Read that sentence carefully because he is not saying the benchmark scores are behind. He specifically names the gap as agentic execution, and on raw benchmarks, Google is fine. Gemini 2.5 Pro with DeepThink just posted some of the strongest reasoning and science numbers ever published by a public model. So the problem is not that Gemini cannot answer a hard coding question in a single shot. The problem is that Anthropic's tools can autonomously carry a messy, multi-step engineering task from start to finish, across many files, many steps, many corrections, and Google's cannot do that at the same reliability. Google's own chief financial officer put the comparison in the open. Anthropic codes close to 100% of its work with AI. Google sits around 50. That is not a gap in the model weights. That is a gap in product tooling and the harness, the scaffolding around the model that lets it take actions, check its work, and recover from mistakes. And you do not close a scaffolding gap by adding a training phase. Those are different muscles entirely. Which brings me back to the people who walked out the door, because there is a physics here that the strike team simply cannot repeal. The knowledge of how to build the next great coding model does not live in a document or a training recipe. It lives in the researchers who have the taste to know which data actually matters, which failures are fixable and which are dead ends, which architectural bets are worth the compute. Anthropic did not merely gain headcount, it gained the specific humans whose fingerprints are on reasoning and pre-training. So Google is now attempting to close the gap using mid-training at the exact moment it lost the pre-training and reasoning experts who would know best how to do that mid-training well. The timing is almost unkind. Let me make that agentic execution gap concrete, because it is easy to wave at in the abstract. Picture a real task, take a failing test in a large repository, trace the root cause across a dozen files, write the fix, run the whole suite, notice that your fix quietly introduced a second failure, and repair that too, all without a human babysitting every step. That loop is not one clever answer. It is dozens of small decisions chained together, each one depending on correctly reading the result of the last. Where models actually fall down is not knowledge, it is the accumulation of tiny errors over a long horizon and whether the system can notice a mistake and recover from it. Anthropic poured enormous effort into the harness that makes that loop reliable, the retries, the tool calls, the self-checking, the verification. That work is engineering, not a training recipe. Mid-training can make each individual step a little sharper. Now let me be fair, because I refuse to be the guy who only narrates the downside. Google has more compute than almost anyone on Earth, and it just raised an ocean of fresh capital specifically to buy more. It holds proprietary data most labs would trade a limb for. It has distribution to something like 2 billion users, which means any improvement ships instantly to a planet-sized audience, and mid-training done well. If any single organization can brute force a coding comeback through sheer resources, it is this one. And delaying Gemini 3.5 Pro rather than shipping a model with known token efficiency problems was honestly the correct and disciplined call. So nothing I am saying here means Google loses the race. What I am saying is narrower and I think more useful. The plan they are advertising is not obviously the plan that actually wins. So here is my verdict. The mistake is treating a strategy problem, a product problem, and a talent problem as though it were a training recipe problem. Because a training recipe is the one version of the problem that fits inside a quarter and inside a memo. You cannot mid-train your way out of the fact that the people who would design the winning approach now work down the road at Anthropic and OpenAI. You cannot mid-train your way to agentic reliability that lives in tooling, not in weights. Google will very likely ship a stronger coding model in the back half of this year, and it will probably be good because the raw ingredients are frankly absurd. But if that comeback happens, it will be despite the strike team framing, not because of it. So here is what I would tell you to watch. Watch what they fix, not what they retrain. If the next Gemini finally closes the agentic execution gap, it will be because Google rebuilt the harness around the model, the exact thing Brin's memo actually pointed at, and not because one mid-training pass performed a miracle on the weights. The band-aid is real, the wound is organizational, and organizational wounds do not respond to training data. If this breakdown was useful to you, that is the entire point of this channel. Cut the hype. Subscribe, and I will see you in the next one.